Hi, and welcome back to Blockchain Fundamentals with Bill Laboon. For this final lecture, we're going to walk through how to create a simple smart contract using the Solidity programming language. We'll be using the Remix Ethereum IDE, which you can see on screen here. And what we're going to do is develop a very simple smart contract which will allow different accounts to set a favorite number. So this favorite number, we will associate a particular account with this favorite number. Everyone can select a favorite number. And we will then add some more checks and balances onto the system as we go along, but this will be a very simple smart contract just to get you introduced to what Solidity is and how you can actually make a smart contract. Obviously, we're not going to go incredibly into depth on all of the syntax of the language or all of the different things you can do, or especially, and this is really important before you develop your own smart contracts, all the security issues. So before you launch a smart contract, you really should make sure that it is very secure. It's been audited. You've used static analysis on it. You've got good unit tests. But as I mentioned, these lectures, they're relatively short and just an introduction, and so we're not going to go too much into depth on those. This is just to give you a flavor of it. You certainly will not be, after this one lecture, a full-fledged Solidity developer. So why did I choose Solidity and Ethereum? Well, Ethereum right now is probably the biggest smart contract chain out there, and Solidity is one of the most used smart contract programming languages. So let's take a look at this. So we can see at the top, I just have a comment, the / with the license identifier, just letting you know this is an MIT licensed program, which means feel free to copy it. Just please, in case you want to make your own smart favorite number smart contract, as long as you give me as long as you let people know that I did it and you attribute it to me. I did it originally. So this pragmas are instructions to the compiler. So what we're saying is that you need to have at least version 0.60 or greater of the Solidity compiler. Actually, we're going to be using some very simple Solidity here, so we probably could do this at an even lower compiler level. The current latest compiler is the 07 series, and you can see that on the left there that I'll be compiling this with 07.2. So 060 should be more than fine. And you'll see the contract favorite num and then the open and closing curly brackets. If you're used to JavaScript or Java or C++ or C, then the syntax of Solidity should not be too surprising. It doesn't have really different syntax. It's not something like Lisp or like an ML-based language like Haskell that has something very different. This is sort of the standard algol style programming layout. So we have here our blank contract, but that doesn't stop us from compiling this. We're just going to have a very, very simple smart contract. So here on the Remix, I first am going to have to compile this program because I need to put it into the bytecode so it can actually be run on the blockchain. So we can see here I'm going to compile favorite number sol Solidity file. And the next thing I need to do is to deploy this. So I could deploy it to various places. I could actually put this on either a testnet or mainnet of Ethereum. I'm not going to do that since I'm still working on it. So I'm going to use this local version, this JavaScript VM. I'm just going to use a local version to deploy it to so that I can test it and add more features onto it before I'm ready. But just like running your own web server, if you've ever developed something on Ruby on Rails and then you run it locally, no one else is able to access this. It's my own little test network on the computer. This also is going to let me have access to a couple of different accounts. Again, none of these are real. I don't actually have hundreds of Ether that I can use for things. This is just a fake local network that I'm going to have these accounts, so I can do things with different accounts, quote unquote different accounts here. So I'm now going to deploy. And I can see creation of favorite num pending. And if I look down, I can see that we do have favorite num deployed. So, but again, there's really nothing we can do here since this is just an absolutely blank, contract. So let's get rid of that. So I no longer have contract instances to interact with. And let's actually do something. So what I'm going to do is add in a variable. Very simple variable. It is a uint32, which means it is an unsigned 32-bit integer called number count that is set to the value 0. And it's public, which means that anyone can access this. So I'm going to save this. I have my brand new smart contract that now has a variable in it that any part of the contract can access, and as well as anyone from outside of the contract. So I'm going to compile this once again. It is compiled, and I'm going to deploy it. So now I have this deployed, and there's one more thing that I can do here. So you'll notice this blue button for number count. I can access the number count variable. So you can see I made a call here. We can click on this to see a little bit more details about what the call, what I did in this call. And what I get as the output is 0. Now if I change this around, so that my variable is 7, and I have to recompile and redeploy. This is a very roundabout way of changing a variable. Now, when I do number count, I can see that the result I get is 7. Okay. So this is, again, very, very basic here. So let's try to add some something we can do that can actually call into this. And we're going to set it so that people can actually set their favorite number. So the next thing we're going to need to do is add in a function. So here we have an add favorite number where we can set our favorite number. For right now, let's change this. So you can see we're going to pass in a 256-bit unsigned integer for our favorite number. We're going to add a variable for that, uint256 favorite num. Just to differentiate these, we'll start at 0. Okay, and we'll set favorite num, which is is this variable, remember, is equal to favorite num. And so we now have a function that takes in a favorite number and sets it. Let's add another function, a getter function, that will get a favorite num and will return that favorite number. Let's call it favorite number. Okay, so this is just going to return favorite num, which again is here. Yes. I probably should set this to be public. Yep. Don't worry. Um, Here, what all this is telling me, and love the things about IDEs, is because this is not actually modifying anything, what we can do actually, instead of making this public, we can actually make it view. So what view is going to do means that this is not going to affect the state at all. It's just getting a value. So we can add this view in. It actually won't be a problem if we don't add it, but it's a good thing to add. So here we now have a very simple mutator, right, where we add favorite num, and then an accessor or getter, get favorite num. So we can think of this almost as just like a getter and a setter in an object-oriented language. So let's recompile. Compile favorite number and deploy. So now let's try interacting with this. So I can see my number count, which is just a value. We've set it now. The favorite number right now is 0. So let's say my favorite number is 23, and I call that. Right, so you can see here's the call that was made. Here are the details of it if you're interested. You can see that in hex, it's 0x17, which is equivalent to 23. So now let's get the favorite number. So you can see the last time we called it, it's 0, because that's the default. But now it's 23. Okay, excellent. So we now have been able, if we want to change it, so our new favorite number is 42. And now when we get the favorite number, it's 42. All right, very cool. So we probably want to be able to store more than just one favorite number. Remember, our goal is to have one of these for every account. So instead of having a single favorite number, what we're going to do is make a mapping. So a mapping is just like a map, or you may have heard referred to as an associative array or a dictionary or a hash, but basically a way for you to make it's a data structure that allows you to have a key and a value. And our key is going to be the address of whoever called this function. And the value is going to be the number that they passed in as their favorite number. So let's, I'm going to add a little bit of code here. So instead of just having, favorite num here, what we're going to do is have two lines here. So now we have this map, and we're going to say message sender, that is the address of the account that sent this, is going to be like our lookup. It's going to be our key. And we're going to set the value for that to the favorite num, the value that we passed in here. We'll also, just so we know how many times we called it, we'll add number count plus plus. All right, so we're going to increment number count. This is so plus plus is equal to number count equals number count plus 1. So you'll notice my IDE is yelling at me because I no longer have this favorite num. I now have this map of numbers. So I'm going to get rid of favorite num. I'm going to have you pass in an address type. An address type is a special data type here, just like we have unsigned integers. We also have address called ADR. And then we'll return numbers ADR. All right. So now when I set my favorite number, it's going to be associated with my particular account that I call this from. And the only one that will be able to send this is going to be my account. No one else can set my favorite number for me. So let's kill this deployed contract. We're going to recompile and redeploy to our local. All right, redeployed. Oops, I did it twice. Let's get rid of one of them. Oh, got rid of both of them. Let's just. Let's just deploy again. There we go. All right, so here I have 0. I haven't added any, so I'm going to add my favorite number. You can see I'm OX5B3. So add favorite number. My favorite number is 90. All right, I'm going to get my address here. So I copied my value to the clipboard, OX5B3. I'm going to get the favorite number for OX5B3, and it is 90. If I try to get it from a different address, I'm going to get 0. Because by default, if a value doesn't exist here, it's going to give me 0. So you can see this account, because it's never been set with a number, it's going to be 0. So just for simplicity's sake, we'll just say that numbers have to be positive, okay, positive integers. All right, and a 0 will mean that it hasn't been selected yet. Obviously, we could fool with this a little bit, but let's just, for simplicity's sake, say that it has to be a positive favorite number. So, but there's a problem with this. So, what happens if I try to say that we can't, you can't choose a new favorite number. Once you decide a favorite number, it's always going to be there. We also want to make sure that somebody can't accidentally set this to 0, that they can't set a number as 0 when we want it to be a positive number. So now we're going to add the require statement. So I've got 2 requires for when calling this function. So first, I want to say that the favorite number has to be 0. And if not, give the message that the favorite number must be positive. And require that the new favorite number has to be 0. And require that the number right now for that sender is 0, which means it hasn't been selected. So when someone calls this add favorite num function, if the either of these requires fail, so if they try to set the number to 0, or if they try to pick a second favorite number, then no change will occur. Generally, you want these requires at the very beginning of your functions. Make sure that before you actually do anything, that you check that all the parameters are good. And if either of these requires are met, or rather are not met, right, then the whole function will fail. Like no change in state will occur. So let's try compiling this and seeing what happens. So make sure we don't have any deployed contracts. Recompile and redeploy. So I'm now at OXAB8, and I'm going to try to say that my favorite number is 0. And you're going to see I got a failure here. So we can see VM error revert. The transaction has been reverted to the initial state, which means no matter what happened in this transaction, it's not going to occur, and all the gas is going to just be burnt to no avail. So we can see reason provided by the contract, favorite number must be positive. Similarly, I can set the value. So let's say my favorite number is 9. All right, so that's positive. And for this address, my favorite number is in fact 9. And now let's say that I now want it to be 9,999. So I try to add favorite number, and once again the transaction fails. Why? Because number's message sender was 9 and not 0. So now we've got a simple mapping and a way to set values for each account and a way to end it. Another thing that you might want to add to your smart contracts is the ability to let watching systems know what's happening. So one thing we can do is emit events. So how we can do that is we're going to need to say what kind of events this contract can do. So in this contract, we'll have one simple event that will fire every time someone adds a new favorite number. So how we can do this is we are going to emit an event. So I've defined the event here. Event, number added is the name, and it's going to take two arguments, an address and the number that they set, their favorite number. So after everything happens with add favorite number here, I'm going to emit a number added event with the message sender, which again is like, a special. So message is like, the message that came in to call the function on this smart contract. And we are going to also add their favorite number. So when this happens, an event will be emitted. All right, so we now have a full smart contract here. Again, a very simple smart contract, but one that will work and that can be deployed. So it has all the features that we want. It has a way for us to add favorite numbers. It has checking to make sure that we're sending invalid data. It has a way for us to retrieve favorite numbers. It also has a way for us to view the number of favorite numbers that have been added. And now we're going to be able to emit messages every time that a new favorite number is added. So once again, let's compile and delete our old smart contract and deploy. So I now have this deployed contract. Now let's walk through this all the way. So we start with the number count. We have 0. Anyone whose favorite number we try to get is going to give us 0 because no one has selected a favorite number yet. So let's add a favorite number. So 1, 2, 3, 4 is going to be the favorite number of this account. And we can see down here that everything is going well. If I try to get this favorite number, it's now 1, 2, 3, 4. Let's add a few other accounts. You can also see, my ether is decreasing microscopically whenever I make a call. So remember, this is how it works, right? We're going to use our ether to get gas, which is actually going to perform the computations. That's one of the reasons, actually, this get favorite num, the fact that it's view and nothing actually gets modified here, no gas will be burned. So I can keep calling get favorite num, right? And my ETH, well, now is not going to change. So you'll be able to see that the number of ETH will never be reduced from calling these view functions. So if I keep getting this account, get favorite number, so you can see I have, let's move over to OXAB8, which has 100 ether. And I try accessing get favorite number. And I do it again. And I look here, you can see it still has 100 ether. Since it's a view function, it doesn't modify any state, and so it doesn't cost any gas to actually do anything. So let's now follow this whole thing. Let's add a favorite number. So add 7, add favorite number. So you can see that there's something slightly different here with logs 1. So you can see that an event occurred, right? Our number added event is included here, which it was not before, which gives us a chance every time we add a number here from a different account, that we will see in the logs that this number was added. So we can see that the event occurred. We can always keep an eye on number count. We can see that there are 2. And we can always get a favorite number. So this one never, this address never set a favorite number, so it's 0. Whereas OX17F, remember I'm not OX17F, but I can access it because it's publicly accessible. All the data in this contract is accessible and we can view it. So hopefully this has given you a nice view and a taste of what all you can do with smart contracts. So again, this is just a very preliminary introduction to Solidity, but hopefully it'll also give you a really good idea of what you can do, and you can build on this in the future. Right. Thank you very much for both for watching this lecture, as well as making it to the very end of the Blockchain Fundamentals course.